Thank you for coming. It's really surprising to see so many people on the last day just after breakfast. In today's session, I'm going to talk about some common design patterns and potential mistakes that can affect security posture when you are deploying AI or machine learning in your environment. A little bit about myself. I've been working in information security and cybersecurity for more than 18 years, out of which the last 3 years I've been working with various AI and ML technologies in cloud for mostly for Google, but currently I'm working for NVIDIA. A fun fact about me, I'm a big fan of remote working. And I'm happy that AI and ML technologies help achieve this to some degree. Let's get back not to so fun things. We know that everybody now uses AI to some degree, so it can be just as little as asking something from ChatGPT or even from AI-powered search engine, and all the way to developing very own in-house machine learning solution and creating and training absolutely proprietary model. And in any case, there is always room for mistake. No matter how little you do, you can still do some errors. That's a sad fact. And the good fact is that we are now sharing the experience, and we will learn about some most common design patterns and how to detect them and how we can avoid and use better patterns. So let's start with the biggest mistake or misunderstanding that surprisingly many companies have is not completely understanding what is the ML ops, so machine learning operations. Many companies think that fine, they are acquiring some machine learning model, or maybe they accrue some data and they verify the data is probably okay. They are training model, they are verifying the performance, and now cool, they put this model in some registry and they start serving it on endpoint. I believe at this point everything is good and you only need to care about the model serving endpoint protection. So like DDoS, maybe API security in general, authorization to API endpoints, and so on. So this is a fundamentally wrong concept, because as you can see on the next slide, it's much more than this. So the real picture usually looks like this. When you have your model, it's a living thing, so it's evolving over time as new data is ingesting, as new prompts, as new tasks are performed using this model. So you still have to remember that you have not just one store where you store your model, you also store model metadata, you store features, labels, you store some metrics about this model, how it is performing. Is it starting to perform worse than originally? And are some users with malicious or not intent trying to circumvent this model? And basically you have secure software development lifecycle on steroids, because model is not only code, but model is code and data together. So with this understanding, let's see how you can understand what to protect and what in principle you can protect and what is out of scope of your control. I will be using this matrix, which is very similar to what you have seen for the cloud security. Like you have infrastructure, you have platform in the cloud, or you may just have software as a service. So in case of AI, you may have just as little as consumer app, example is ChatGPT. You can have some kind of enterprise app, which is the closest to definition of software as a service. And you may have some pre-trained models that you can download, for example, from Hugging Face and similar site, and then with this pre-trained model, you can do some fine-tuning, or you can do augmented generation if you want this model to work with your proprietary data without exposing it to outside world. Then you can have more sophisticated training and fine-tuning on existing models, and finally you can just completely develop and train model on your own. So that would be an analog when you don't go to cloud at all, and you just have your own hardware and everything you control. You can use some kind of a diagram, just as with the cloud shared responsibility. So this example is for using pre-trained model. In that case, you normally do not control initial training data. So you have to trust the supplier of your pre-trained model that the data was accurate. And here, it would be ideal if you could have some kind of equivalent of ML bill of materials. Thank you. Sorry. Okay, in this case, it would be nice to have some kind of ML bill of materials, just by analogy with software bill of materials. So you know where does this data come from, and what is the amount of data, and so on. So you do not have control on how this model was pre-trained. But what you do have control over is customer data and the application itself that you develop on top of this model, and potentially any kind of augmented sources of data that are used to enrich the operation of your application. And you do control in which way users interact with your application. So you can control what kind of prompts are allowed and what kind of responses are generated, and you may filter both. So that is like some middle case. That's why I put it on this slide. And I would like to talk a little bit about the difference between scope 1 and scope 2. It's a little bit mixed border, I would say, between consumer AI and software as a service AI apps, because let's say OpenAI ChatGPT offers you either using their interface, so just like web or mobile app, and at the same time they are exposing their API, and in certain cases, you may select which model version you can use. So if you use this paid subscription, you can work with 3.5, or you can work with model version 4. So typically for consumer AI, you do control input data, so you can do this on organizational level. You can say users are not allowed to input this and that into prompt. Or you can control it on certain technical level if you put some filtering. And you can control which methods users would be allowed to use to submit prompts. You can say only through the mobile app, or maybe you can allow all methods. So when it comes to software as a service apps, those examples include usually some enterprise-wide solutions, such as Copilot or Duet AI, and so on. So in this case, you control a little bit more, because you are still able to use augmented generation, and you have more control over the plugins that you are using. Because what usually happens is that you have a very large amount of data which you would like to be instantly accessible by the AI agent. You do not rely mostly on user manual input like in cases of consumer AI. So as you can see, minor differences. That's why the security protection measures are also very similar. So let's see how we can detect and prevent misconfigurations. And I will be focusing on scope software as a service application to fine-tuning model. Because complete development of their own machine learning model is a process that is complicated, and I would not have enough time. But after this presentation, just feel free to ask if you have questions specific to this scope. So what I found useful, what kind of measures and mitigations you can implement. You can use good old NIST CSF, Cloud Security Framework, and you can map it to the techniques that are specific to AI attacks, and they are presented, for example, by MITRE ATLAS. There are several mappings available from different organizations on the internet, including some advancements from Cloud Security Alliance. But you can also make this mapping yourself. So after that, you would have a nice spreadsheet. And one example, for example, includes a published poison data set that is from MITRE ATLAS. And against this, you can have mitigations of getting a checksum verification whenever you pull the data set into your model. So this is good as a checklist. And in general, all the countermeasures to potential attacks can be divided into 4 categories. So in the middle, you can see everything that's relating to the model guardrails itself. So you do not let model to drift, you don't let the model to lose the performance, and 3 other guardrails are related to how model interacts with the outside world. So you can control input in any of the 5 scopes. You can control output also in any of the 5 scopes, and in scopes when you have your own cloud deployment and you have access to underlying resources, you can also control how the resources are scaled. Because sometimes it's important if you have too many requests to your model and you don't cap the resources, you may have either a huge bill or an equivalent of the DDoS attack. Typical components in the cloud with which your AI/ML solution will be interacting with is, of course, identity and access management, anything that comes to controlling access to the data and the output of the data. You may be able to control ML algorithms itself and their software composition. directly or indirectly. So directly if you develop it, and indirectly when you select the vendor of your solution. Then you have to observe certain licensing limitations. And if you have control over compute resources, as I discussed, you would be protecting them just as a normal way you protect resources in the cloud. And you have control over your data. So whenever you store in your cloud, you have control over it. Let's see some examples for identity and access management, something that I faced very early when I started in working with AI security is the Jupyter notebooks that are used now by almost every cloud ML studio, ML training solution, is that those Jupyter notebooks and their service accounts have a lot of access to be able to perform training. And by default, there used to be granted a user with equivalent of root access, which means that whoever gets access to the Jupyter notebook can just exfiltrate all the data. So nowadays it's mostly fixed, but still worth looking at. So you have to, in general, identify what roles, what service accounts your AI and ML solution works as, and you need to have clear visibility into where this account has access to, because otherwise it could be a proxy for the attacker. If they take over this account, they have access to everything, almost like some domain administrators in Active Directory. So the way to prevent this kind of lateral movement is to break out the machine learning workloads by access pattern and limit them. And in that case, if one of the accounts is compromised, the blast radius will be lower. Also to avoid misconfigurations in IAM, you can create pre-provisioned environments or infrastructure as a code with those predefined roles, so you don't have to manage them separately. And then you can do the development environment and enroll the same pattern for the test, QA, and production. Regarding to machine learning models that you develop in-house, as I already said, they are a combination of code and data. And in the aspect of code, you just treat them the same way as you would treat your in-house developed code. So you do a static analysis. In certain cases, currently there is no malware that would affect machine learning models in the wild, but I have seen some proof of concept. So because it is a code, you can actually try and execute some malware. Just as the same way as for your normal code, it is strongly encouraged to use private Git repositories, as you don't want your model to leak if you are not ready to share it with the world, and you don't want some random people commit. And you are also using the private container registry. And where you store your models and environment where they are running. Of course, you sign and you encrypt containers. So in that sense, there is not much difference. So it's not some Eureka model, but some people just forget that models are not only data and not only parameters. How would you manage the software composition? Also the same way. So you are using trusted sources for all the packages. So whatever packages you are importing in the code of your model, you need to be sure they're coming from trusted sources. Ideally, this import and installation should be automated. And you should understand that some machine learning packages also like to collect data. So whenever you are thinking of using some package, just double check it doesn't learn on you if you don't want it. Licensing concerns also the same as of the code. So whenever you select which framework or which libraries to use, you are using the same tools as for open source licensing management, or if you use some proprietary packages, make sure you have appropriate rights. When it comes to resources, so usually for ML, there is, again, some kind of a container structure or containerized structure where they run. So make sure that nothing is leaking if you are using internode container interaction, enable encryption, and the most important, set limits on resource usage. Because model training or model operation can be very resource exhausting, and you do not want it to explode, so to say. So if you are using some training data that was not just supplied with a pre-trained model, again, use trusted data sources. Verify if the data can be used for the model training at all, if there are any concerns regarding this. So if this data is maybe a subject to some legislation like GDPR or US specific, maybe it's healthcare data, have a plan for what would you do if the subject of this data withdraws their consent. So are you able to somehow remove it from your training data sets? Yes, and on the cloud level, of course, tag data in buckets where it resides so you can find it easier. A special mention goes to augmented generation. So it usually comes handy when you are using copilots or code whisperers, such augmented solutions. And here you need to understand you cannot just allow access to the, all of your data to AI agent. You have to select very carefully, because otherwise it can just go all over the documents, and it can use the data that was never intended to be used by this AI, and some employees or some consumers of your solution may get some surprising results. You should have full transparency in what data is accessed and how exactly it is used. If you are using, like in most cases, you are using vector database for it, so you may think of some compartments and do not store all the data indexing in just one vector database. And that brings you more control. Other techniques you can use for the RAG is data anonymization. You can use query validation to prevent the analogs of the query injections. Of course, always generate, validate the generated content before you serve it to users, and check if the user has access rights to whatever control is being output. And a small side note that not all AI agent may run in some server and the browser. Some AI agent may also run on IoT devices. And it is again a very separate topic. For example, this AI agent may run on the automotive. And you should understand that when you ship your model on the edge device, like this car, you are losing a bit of control over it. So at least you should have some safeguards. Depending, for the cars, there is even the automotive security standard that first of all, you're cryptographically signing your model before shipping it to the device, because you don't want the car to run on some kind of auto-driving software that was replaced while you were putting it over the air update. And you should understand also you would have limited resources on the end device. So you may choose to select a lighter version of framework there. So like, for example, TensorFlow versus TensorFlow Lite. And don't forget to monitor. And with this, we are coming to the last but not least section about monitoring. So what I was talking before was more like preventive measures. And now those are detective measures and auditing measures. So what things you want to monitor? Endpoints, of course, because that is what is facing the customers. But for machine learning and AI, you also want to monitor such things as how it is performing in terms of accuracy. Does it has any biases as it ingests new data? And if the data in your model drifting from what was originally intended to train it on. Different cloud vendors have a little bit different solutions for this. And most of the vendors also have such thing as a model card. So model card is like a passport for the model. You can input such things. What is the purpose of this model? What was the initial accuracy? How the accuracy has changed? What are the data sources for this model? What is the data classification that was intended to work with this model? So in that case, also when the auditors come or you want to exchange your model with your partners, you have this passport ready. So it is like a performance history and a bill of materials. And the checklist here would be more or less still the same, considering only the additional thing that you need to monitor for biases and accuracy. So always verify that you are logging enough. So you can trace back when some negative change has occurred and who was the source of this change. So if there are some, like I don't want to go too deep into the machine learning because I know it requires like 5 years of training. So you can monitor certain patterns. You should discuss it with data scientists, how they can understand somebody is trying to poison your model. So what would be some negative trends? There is no unique solution to this, because it depends on what is the task of this model. If it's generating pictures, if it's giving you medical advice, or maybe it's evaluating CVs. But you must be able to understand this, and you must configure your logging appropriately together with your data scientists. So you must be able to identify those patterns before you are moving to production. So you should have this logging configured not only in production, but also in your test environment. And you should know how to roll back your model if you start seeing those negative changes. Okay. And how can you redeploy the previous version of model, which still works as performed. I got two examples because I'm trying not to promote any single vendor. So some popular examples is for AWS, how you monitor for data drift. So you can see there is a training job for the model, and each time it is running and is being served to the application. There is this cloud metrics that were developed by AWS already in ML in mind, which makes sense to data scientists. And using them, you can use either some predefined rules or maybe human-based verification to see if the model is, after the training job has completed, if the model has drifted, and if it drifted too much, then you can do the rollback. You can basically undo the training job for it. And another example is for Azure here. So so this example is for like consumer-based Gen AI. You can log all the interactions of users with your model, and you can trace back on maybe who is trying to provide some malicious prompts and to put your like to poison your model or to force it give undesired results. So that was it. And I hope I have left enough time for the question and answers. And thank you for your attention.
Good presentation, thank you. I'm curious, like at the end when you talk about monitoring for inputs and outputs and looking for malicious things there, how do you protect that, or have you seen best practices? Like if somebody is submitting data that's sensitive to your model, you have to log that to see what the response is? Like, have you seen tools and processes for protecting data submitted to the model?
So if we go back to this slide, you can monitor all the interactions of users, and because it's a plain text in this case, you can use some data finding patterns, like a DLP solution which comes with Azure or a third-party solution, and to see if somebody is submitting social security numbers, or if somebody is submitting something like a credit card number. So that is one way. The other way is you can change the prompt input in that way that it's only possible to have some pre-formatted messages. Like a chatbot, sometimes it just gives you some options. What do you want to do?
Appreciate the presentation. Have a question going back to comment on GDPR, right to be forgotten. In the case where you have a user that has requested to be forgotten, say 6 months or 18 months after your training has taken place, are there techniques or approaches for pulling that training out of the model?
So it is, I'm not aware of any techniques to roll back the influence that this initial data had on the model. However, if you mark the buckets or whatever storage you have for this particular user's data, you can remove it so it will not be used in further training. Mm-hmm. So that is the one thing you can prevent.
Okay, and the other question on top of that is, when you're looking at hundreds or thousands or millions of potential users, What are your thoughts in terms of how you scale that capability when it comes to that right to be forgotten when we're dealing with models?
So in which sense scale? So let's say user says, here is my full name, here is my email address and social security number. Please remove me from the data. So we know that this user's data is being stored in this bucket or set of buckets. So we just go scan using regular software that we use for data detection and GDPR compliance. And we remove and provide the user with a report, you were removed from our training data sets. And to ensure that this particular user data will not be provided in the output, we use also data anonymization. So we want to ensure that the social security number will never be popped up in the output. So even if the model generates it, because I already told you that we cannot undo the training itself, it will be filtered out.
Yeah. Okay, thank you.
I had a question. Have you seen AI models used in a supervisory capacity to kind of monitor performance of other models? I
think there are some startups that are doing it, but so far the most advanced I have seen is a model that goes across the logs of the other model and tries to find some pattern. To see that if the data drift is occurred or maybe significant shift in performance that says that the data is being poisoned or skewed or something.
Thank you.
One other question I have regarding WAF technologies out there now on the market. So the prompt injections, how these technologies are ready now? Do you think it is ready for protecting these prompt injections, WAF out in the market right now?
And there is never a such thing as a perfect protection. So usually it can protect against some known attacks. So that would be probably enough to protect from people of level of script kiddies that just read some article. Hey, here is how you can do this with our mocking. Again, I think the company named Lakera had their CTF Gandalf AI. So you can see how different levels of protection make it harder for the attacker to do this prompt injection. But in the end, even if you go to level 10 or a level 12, there is still some way to go around it. So it's only like how expensive and how much time will it take for the attacker.
I guess kind of a technical implementation question is, you use the example of Amazon SageMaker of not providing root access. Is there any control or way you can kind of like meet the middle of not giving full root access or no access at all?
No access to what?
For your example of AWS SageMaker removing root access, if there's no root access, there's no.
You can reduce the access that it has because normally it doesn't. So I was mentioning the root access for the Jupyter services in particular.
Okay.
So now it has been fixed, so it's no longer works as root. It was just like this because they have integrated, because Jupyter is a separate product. Yeah, so definitely now the access rights have been significantly reduced, and in addition to this, you can make those compartments with data. So you have compartment with data that is personal data, then you have like financial data and this, and you can create, instead of one agent, you can create like 3 or 4.
Thank you. So one of the things that I do is review the security of vendors and potential vendors. When people in my organization want to use a new service, they come to me, say, we're going to buy this. sign here, kind of. So I put them through a security review when that's needed. And I'm unaccustomed to reviewing vendors that now use these multiple AI architectures. Can you tell me, knowing what you know about application architecture and security, is there something new that I need to be asking? And of course there is. And I've got some questions for them from like the OWASP top 10 for AI. But other than things like that, what would be a couple of important questions to ask these vendors?
There would be new questions compared to software bill of materials.
Yeah.
Because the model is code and data. So you need where their data is coming from, how they perform some verification of their data, and you need to ask if they will be using your data to train their model and deliver it to other customers. Okay. Because if they do, you may be in legal trouble.
Sure.
That at least this,
Okay.
compared to the normal code.
Okay, thanks.
Hi, this is Rakesh here. I would like to extend the same question that gentleman asked. So this model may be internally using some open source technologies and some additional model to build upon it. How to mitigate those kind of risks, because it's a nested thing, like a model using and consuming other model for enhancement or enrichment of the model itself.
So in the same way you manage licenses for open source and free software. So usually model includes some licensing information, which your usually lawyers or maybe developers who are proficient in this licensing management can evaluate, and they can tell you any potential risks if you are using it. The other concern can be if you are using the, let's say, open source code to train your model, and then your model starts speak in this particular open source code. So you may want to check that whatever your resulting code output licensing is at least at the same level of strictness as the licenses of the code that you were using for training.
So
it's a little bit complicated.
Yeah, I'm trying to go to my question, like have you encountered any particular tool, just like Black Duck is for software application, open source findings and other. Have you encountered any tool that is relevant for this kind of use cases for model?
Right now we are doing this manually. So we limit the number of training sources only to the code that is of favorable types of licenses. And we instruct our developers not to feed any non-approved code into the model.
I see. Thank you.
I came up with another question. Can you point me to any specific training for the developers that we have on staff who need to integrate either third-party apps or our own development processes? Any favorite or suggested training that's available?
Some training is available. I have seen on this early stage expo, there are some companies who are providing it. There is some free training available for developers. I believe the company named Portswigger that is developing Burp Suite.
Oh yeah.
So they do have some training on how to secure the AI endpoints. I hope it's not an advertisement because it's a free training. And some companies such as Lakera. Again, I'm not advertising them, it's just some training that I took myself when I was trying.
Yeah, it's so new, that's why I thought I'd ask you. Okay, thank you.
Thanks for the great presentation. I have a question. Is it realistic to expect like the input guardrail or output guardrail to be able to, prevent all the security issue we're having with the LLM, right? And it's a bolt-on security, right? And also, I guess, it's also a traditional way of handling this kind of I guess, security issue. And LLM, it's like a completely new things. And how do we expect like the input guardrail and output guardrail will be able to prevent all this semantic type of, I guess, security issue or attack we're facing? Do you expect, like, do you foresee, like, eventually, like, those issues will need to be, I guess, addressed inside the model itself, or maybe you will have another layer or another, I guess, specialized LLM just to I guess, do the guardrail job?
Yes, I would say it's always a separate level. So maybe it's as simple as just some basic semantic check or some pattern check. So we do not recommend incorporating those checks into the model itself. So it's like a microservice architecture. Each model serves its own purpose and solves its own task. And as I said, there is no perfect solution, but security is in those layers, that you filter the input and you filter output always before serving it to the customer requested.
Okay, thank you.
No more questions? Okay. Then thank you so much, and have a great rest of the last day of the conference.